Hello, this is Professor Werwath. I wanted to go through what I would consider to be mistakes or sins of the engineering profession. These are major problems, mistakes that have been made over the years that have cost people's lives, that have been, tragic in many ways. And I think these are in many ways also very preventable. So the lessons we can learn from these might actually help all of us, especially as engineering managers. So let's move forward here. Hold on a second. Okay. All right. Let's start with PFAS, right? These are what is sometimes known as forever chemicals. These have been designed into products for the last probably 40 years. Everything from firefighting foams to microwave popcorn bags and eye makeup and fast food packaging, paints and cleaning products and nail polish and nonstick cookware. This, once it's in the body, it bioaccumulates. It does not break down. That's why they call them forever chemicals. The problem with that is we believe that even in small quantities, this can be very problematic to people's health and potentially carcinogenic. So, engineering products with PFAS, or better yet, lately it's been engineering products around PFAS to avoid PFAS because now people are quite aware of it. The problem is it's in our environment and it's everywhere. It's in our water supply now, it's in the raindrops that fall from the sky. It is so omnipresent that it's almost impossible to get rid of. And it's also now in almost every human body on the planet, including newborns, across the world. There's almost no place on the planet where you can, today, at least now, avoid PFAS. So keep that in mind whenever you create biopersistent products and chemicals and compounds. Think about how the environment should naturally break down our products so that it doesn't become part of our ecosystem, a permanent part, where it might almost be impossible to get rid of. In similar fashion, we have lead issues. Obviously, lead is very toxic to the brain, especially the developing brain. We've had lead pipes in this country for a long time. It wasn't until I believe the 1970s and 1980s that we started to recognize these issues and stopped deploying lead in pipes. However, the damage is done. Those pipes are still in the ground in many cases. They're still servicing our communities. The older the community, the more likely they are to have lead in their pipes. And depending on their ability to replace and upgrade those pipes, it might take years, if not decades. And I'm sure the federal government will help fund some of this stuff. But in the meantime, we need to know as engineers, um, we have to think twice and three times about what materials we're using, the potential toxicity, and what impact it might have on the developing brain, on human beings going forward. And I think having proper testing of materials, especially that contact drinking water or anything that comes in contact with food or directly contacts the human beings, needs to be critically looked at. In similar fashion, lead paint, lead gasoline, these have been outlawed for at least 3 decades that I can think of, but the problem is still there. Lead, lead gasoline, lead-based gasoline had tanks underground. Many of those tanks are still there. Much of the paint that was used back in the day, especially used indoors where children can get a hold of it. Little children will have a tendency to want to put this kind of stuff in their mouths. So it's done a lot of damage over the years, and I'm sure we can all learn a lesson from the use of lead in various products such as gasoline and paint. Cyanide is used in mining operations to help remove and handle minerals and rocks. Um, Obviously, mining operations are pretty prevalent in places like China. As a result, they have a lot of cyanide contaminated waterways. So can cyanide make its way into the food system because it's in the water system? Absolutely. Is it dangerous? Of course. Is it potentially poisonous? Absolutely. As a result, much of the waterways in China and elsewhere, right, have been contaminated beyond um, any kind of restoration. Here's a sense of some smartphones. You can see populating a landfill. All of these have batteries. All of these have different types of precious metals. All of these have toxic metals. Even though there might be small quantities, when you have a large, a large amount of them, like you have in a landfill, these things can accumulate. They can become quite toxic. But what's worse is, we design these phones, and I know because I worked in this industry, right? We design them for obsolescence. We want people to churn through these phones, right? Get a new phone every year, every 2 years, something like that, right? So imagine in just the last 10 years, I've gone through maybe a half a dozen phones. Everyone in my family has, everyone that I know probably has. So we're talking about, thousands and thousands of phones just within my network of people. And so those thousands of phones have to go somewhere, right? You can say, well, they go to the used market. Not many phones actually get sold through the used market. Many of them get disposed of. People are worried about security. What happens to the information on their phones? Can you actually delete it completely and safely? A derivative of this problem is, of course, the plastics and microplastics problem. So you see a huge pile of bottles. These plastic bottles were salvaged by this young girl who's going to monetize them as opposed to having them in a landfill. So she arguably rescued these plastics from a landfill. All of these are single-use packaging, right? And single-use packaging is the root cause of a lot of our mentality, right? Just put it in a simple, cheap plastic container, low weight, low cost, easy to manufacture, easy to deliver, and easy to dispose of, I suppose, right? It's either going to go into some sort of recycling stream, and there's some question about how effective that is, and then, or it goes into a waste stream. Either way, it breaks down into microplastics, as you see on the right. Those microplastics are also inside human bodies. So it's not just PFAS. Now we're finding microplastics in almost every biological entity, from birds to fish to human beings, and yes, even newborns. So how does it get there? It's in the food we eat. How about that, right? Almost every food we eat, especially animal products, is going to have microplastics in it. It's just the nature of how we live. So keep in mind that nature has to dispose of the products that we deliver, right? And the more we churn, the bigger the problem is. So I know your marketing people are going to say more churn is better. Of course it is for business, but it's not good for the environment. And frankly, at some point, people are going to wake up and say, I don't want to replace my phone every 18 months. Give me a phone that can last me 5 to 10 years. And there's no reason why you can't. I've had laptops that lasted me 6 or 7 years. A lot depends on whether the software has been updated and whether, the performance is still acceptable and whether the product is still reliable. This is a great story. You're looking at a solenoid, but it's at the bottom of a dishwasher that came out of my kitchen just a few days ago. Why did we remove it? Well, because it had a fatal flaw. It actually failed after about 8 years of operation, which you could say, that's not bad, 8 years of operation. It was not worthy of replacement. I was told it would cost more to replace the solenoid than it would be the cost to replace the whole dishwasher. I was better off just replacing the dishwasher. But you could easily say, well, wait a minute, a dishwasher is not $10,000. It's probably more like 1,000 or even 800. And you're right. The problem is when this dumped the water onto my wood floor in the kitchen, we didn't detect it for about an hour and a half. During that hour and a half, the amount of water, hot, soapy water that was dumped onto the wood floor caused wood floor damage. And to fix that, to replace the wood floor, is easily now a $10,000 or possibly a bigger problem than that. We still have to get the insurance adjuster to come out. We still have to get the repair people to come out. We don't know how long it'll take or how much it'll cost, but the wood floor is damaged, all for this plastic solenoid that even the repair guy said, had they made this out of brass or any other, decent metal that doesn't corrode, it would have lasted, it would not have been a problem. This machine might have lasted me 10, 12, 20 years, who knows? So this is how a simple part like this, which should have been a few dollars, can easily become a $10,000 solenoid. So think about not just the immediate cost of failure, but the downstream costs of failure, right? The ramifications. This is dealing with water in a kitchen. Kitchens these days have wooden floors. In a similar fashion, right? I owned a Nissan Murano in 2007. and I sold it before the engine failed, but I knew of many people whose engines had failed. You could ask, well, this was an award-winning engine. Why would it fail? Why would it fail prematurely? I was told 70, 80,000 mile engines were failing. This car had a timing chain. Timing chains are supposed to last a long time. However, this plastic guide on the right, which is internal to the engine, actually decomposed, and under the stresses and heat of the engine would actually break apart. So those plastic parts, when this decomposes and this starts to break apart inside the engine, would do enough damage around the timing chain to actually destroy the engine. So we're talking about this little plastic part, once again, causing potentially $7 or maybe even $8,000 of damage. It's not just replacing the engine; it's the labor, it's everything that goes in it. So this is a 6-cylinder, 24 valve, very sophisticated, award-winning engine. I mean, it won awards for its design, and yet here it is, prematurely failing. And I've seen them on the rack. I've seen them in the mechanic shop. I mean, they tell me the stories. And a lot of it, at least in this case, was this plastic part here that is basically a timing chain guide. Okay. All it does is guide the timing chain and keep it in place. But when you make it out of plastic, and guess what? It could easily break apart. The Murano was also known for having defective transmissions. So 50,000 mile transmissions, CVT. CVTs have had a history of failures, especially with Nissan. Almost any Nissan CVT prior to 2012 is probably suspect and possibly even subject to recall. Speaking of recalls, Hyundai Kia engines, we're seeing 500,000 cars being recalled because of a debris. This was debris in manufacturing that was left inside the engine, residual debris, metal fragments that eventually make their way through the oil chambers and circulatory system of the engine and destroy the engine. So 500,000 cars. I mean, I've been to the Kia dealer where they had engines. These are called the Theta 2s. The Theta 2 engines were stacked up from floor to ceiling. I've never seen anything like it. And I asked them what's going on. They said, oh, this has been going on for months and months and months, and it'll probably keep going on until they get their hands on all of these hundreds of thousands of cars that are impacted by the recall. Similarly, engine fires, right? I mean, you've got BMW. I'm not even sure what make this is over here. And then this is the Chevy Bolt. The Chevy Bolt only had 15 fires, but they were pretty catastrophic. Again, traced to the battery. This is the traction battery that came from LG Chem. At the time, LG Chem was building these in Incheon, Korea. And these cars were known to spontaneously combust, and they had a complete recall. I know because I had one of these cars. I was forced to park outside. I was forced to park, hundreds of feet away from any other car for months at a time, waiting for my battery to be replaced. The good news is they replaced it at their own cost. It would cost them at least $10,000 or $12,000. I'm told that the total liability to Chevrolet and to LG Chem in this case was on the order of $2 billion. So yes, nobody's been hurt by at least this fire. I don't know about these other fires, but the fire from Chevy Bolt didn't hurt anybody, but there was a lot of property damage and a lot of destroyed cars, or at least 15 of them that I know of. Okay, Deepwater Horizon, I think we all know the story here. In 2010, a blowout on the rig caused an explosion that killed 11 men. A fireball ensued and caused a massive oil spill that took years to resolve, right? So this is a subject of lots of news stories. There's a movie on this, so I'll let you take a look at that. But you can see the tremendous damage from all of that oil, as well as those lost lives, those injured lives. There's the damaged equipment. It was a total disaster, and largely because you could argue improper maintenance, improper procedures, skipping steps, shortcuts, etc. Lots of questions as to what went right and who was to blame, what went wrong and who was to blame. But I'll let you dig into that as best you can. Bhopal is an interesting case study where insecticide and other chemicals leaked from actually a pesticide plant located in Bhopal, India, where basically this MIC or methyl isocyanate gas leaked and killed 6,000 people, or at least it was estimated to be 6,000 people. a total disaster. Again, poor maintenance, poor procedures, inadequate staffing. I mean, when you have something like this, an infrastructure like this, that's so critical to be properly maintained, properly staffed, properly operated, cutting corners to save nickels makes no sense, right? There are situations where, the Alaska oil pipeline was not properly maintained, and then massive blowouts do huge amounts of damage, all because we wanted to save a few nickels. Somebody at British Petroleum wanted to avoid the rust inhibitor, which you'd have to drop in on a regular basis. They said, hey, let's save money. Well, as engineers, I think we should all know that, that those nickels that you save wind up costing potentially millions of dollars, as well as your own reputation or the company's reputation downstream. So is it worth it? Absolutely not. Stand by your ground. There's lots of ways to save money. You can put fewer French fries in the bag at lunch. You can maybe not stripe the driveways and parking lots, but when it comes to something like this, the safety of the communities at stake here, don't put them at risk. Don't put your company at risk, right? I think we all know the 737 MAX story. In my mind, it's a story of a platform that was aged, and they chose not to upgrade the platform. As a result, the oversized engines needed for the MAX changed the aerodynamics of the plane and put it into a natural nose down position, which was offset by some software that was written to bring it back to the nose up position. Unfortunately, the FAA was not made aware of it. The customers weren't made aware of it. The pilots weren't made aware of it. The software was overriding the pilot's instructions, and it caused a lot of confusion in the air, and eventually led to at least 2 crashes that I believe I'm aware of. And those crashes killed hundreds of people. So is it worth it? Were they cutting corners? Were they trying to speed up a process that should have taken longer? Maybe a new platform was necessary. When you create a bigger engine like this for an airplane that's known to be this low to the ground, right? You already have clearance issues. They had to basically push the engines forward to avoid the geometrical problems of having a plane that's that low to the ground. When you push the engines forward, you create an aerodynamically unstable situation. It wants to be nose down. So that's the fundamental problem. It's not a software problem, and it wasn't a communications problem. At the core of it, I think, was a problem of architecture, right? I mean, the basic architecture of the plane was compromised by going with this modification to an aged 737 platform. They should have had a new platform altogether. De Havilland Comet was one of the first passenger, if not the first passenger jet ever put into the air. British made. It was actually quite a good aircraft until it started falling out of the sky. And the reason for that is rapid decompression in mid-flight. And the reason for that is apparently problems with stress cracks and stress, fissures in the fuselage, due mostly to the windows. The windows were square; they had sharp corners, and during compression and decompression of the fuselage during flight and after flight, it eventually created these stress cracks that eventually led to rapid catastrophic failure of the fuselage. So we had people die there. The plane was grounded and eventually permanently grounded, which basically put the de Havilland company out of business and frankly propelled Boeing into a very nice position of having a near monopoly for the, at least the 60s and 70s. And the Boeing 707 becomes this legendary aircraft in large part because a lot of the competition was gone. Planned obsolescence, right? We do this on purpose. We design products to fail. That solenoid on my dishwasher, it's made out of plastic, right? It could have been made out of any metal that would have lasted much better. But by making it out of plastic, you can pretty easily predict when it's going to fail. This is not by accident. I don't think it's necessarily just cost reduction. I'm sure cost reduction was a motivation. But I mean, if you can get a dishwasher to last 8 years, that means I'm buying a new one, right? As opposed to 15, 20 or more years, which is what appliances used to be. So ask anybody in the appliance business, they'll tell you the new designs are not holding up. as well as the old ones. And in large part, it's because of planned obsolescence. Marketing goes to engineering and says, reduce the expected life. We want more product churn. So this is the slippery slope. This is what we all have to deal with as engineers. If you become part of that whole equation, you become part of the problem, right? So what can be done? I'll be bold, right? Refuse to design for obsolescence, refuse to design for maximum churn, design for repairability, design for maintainability, make parts available at reasonable cost and from third parties. Prescribe proper maintenance intervals. You know, there's a lot of people playing games with TCO, total cost of operation. Don't play that game, right? You're not here to make a number look good. You're here to make a product that is good, okay? That will last, that you can be proud of, that is worthy of the brand you're putting on it. Conduct the FMEA analysis to understand where failures are likely to occur and understand their consequences. Failure modes and effects analysis. If you're not familiar with it, look it up, educate yourself. I'm sure you'll find it useful. The same with life cycle analysis. Understand the long-term environmental impact of your designs, right? And not just at point of sale or even 5 or 10 years later, but from basically from concept all the way through to retirement. Every step along the way, what is the environmental impact of that product and all the components that go into it, all the intermediates that go into it. Avoid use of plastics and toxic materials in your designs. Plan for reverse logistics, trade-in programs, and used equipment sales. Software upgrades, at least in the smartphone business, at least 5 years, right? For what it's worth, Apple, Samsung, and OnePlus all give 5 years, 5 years of updates. Google gives out about 7 years of updates. Most every other company, including the Motorola's of the world, only give about 2 years of updates. So you can imagine, by definition, if your phone's not getting updated, you're going to replace it because it's no longer secure. Compete on reliability, compete on warranty. When you start increasing your warranty claims and your warranty commitments to your customer, right? From, let's say, normally 3 to 5 years, maybe up to 7 or 10 years. You start doing that, it forces you to design a more reliable product. It forces you to think through what are the proper materials that will last. And also, it really forces you to have good engineering practice. So as an engineering manager, follow best engineering practices consistently, right? Speed to market should not be an excuse to sacrifice quality or to sacrifice safety. Do thorough analysis of your designs and your changes. Change requests also need to be thoroughly analyzed, right? When swapping out a material for, let's say, plastic for instead of brass, what is the expected life? What are the failure modes? Well, how should the design be changed, right, to make it more reliable? Analysis, testing, thorough testing. Do not skimp on testing, and of course, simulation. Take all customer complaints and field issues seriously, monitor performance in the field carefully, support right to repair laws, and respect them. So supporting them means that there's a lot of proposals out there to change right to repair so that customers can get access to their own software, so that they can get access to their own hardware, the parts, the services, the materials, if everything's proprietary and going through the OEM, right? Guess what? They can jack up the price. They can make it hard to, find those parts, and they can charge whatever they want. Support the safety and efficacy of your products. You are the advocate for that as an engineer, as a designer, and as an engineering manager. And if you say, well, this is impossible, there's nobody can do this, I will give you one example of a company that I think is making steps in the right direction. A company called Framework. They make laptops that are, by design, they are modular. So you can replace all the parts you see here, from the keyboard to the memory, to the SSD, to the CPU, to the battery, anything you want to change out, anything you want to replace or upgrade, it's part of their business model. So they make a modular design so that you can maintain, you can repair, you can upgrade your own products without having to replace those products. So this will reduce churn, and they probably know that, but part of their product mentality and strategy is to deliver a product that will last a long time for you and something that you can grow into and upgrade along the way. So if they can do it, I think you can too. If they can do it in this industry, I think other industries could also learn from their success. So take it from there and think thoroughly through what I had to say in terms of what you can do as an engineer and as an engineering manager, because you have much more influence, I think, than you realize. You need to draw the line in the sand and recognize that if you don't compete along these dimensions of quality, reliability, and warranty, somebody else will. Take care.